Good afternoon. This is Peter Esselman from the USGS Great Lakes Science Center. I'm very pleased to have the opportunity to present to the Lake Huron Committee today some of the progress we've been making using our Gobybot system to assess round goby abundances in both Lakes Michigan and Lake Huron. Today I'm presenting with Chuck Medengen, also from the USGS Great Lakes Science Center. Since the arrival of round goby to the Great Lakes, fisheries managers and fisheries scientists alike have become quite concerned with their status and trends through time. This is particularly important as round goby have become an important prey item for lake trout, lake whitefish, yellow perch, walleye, and other species. USGS's round goby estimates coming from our annual bottom trawl survey are assumed to be biased low, and that is due to the fact that the bottom trawl can only sample over fine substrates and the vessel can only operate in depths greater than 9 meters, and we know there's gobies occurring shallower than that. The recent bottom trawl estimates from 2015 to 2019 show relatively low biomass, typically below 0.3 kilograms per hectare, and the overall community biomass estimate for Lake Huron, shown up here, doesn't even have round goby as a slice of a pie. Due to the biases and the importance to predators, the Lake Michigan Committee and the Lake Huron Committee have called for improved estimates of round goby, and USGS has gone about developing and innovating a new system, a robotic system, that images the lake bed to provide such estimates. Very briefly, the way we use Gobybot to arrive at lake-wide biomass estimates is as follows. Gobybot is tasked to fly transects of about 10 kilometers at 1.75 meters altitude, collecting a continuous photo transect. Each of the photos coming off of Gobybot has a latitude and longitude associated with it, which allows us to map patterns in biomass variation. Once we have images screened and we know they're usable and we have fish in them, we send them off for annotation, which is essentially people find the fish and put traces on them. We've been using these traces to automate the tracing of fish, but that is not a solution that's ready quite yet. Either way, once we have the traced outline of the fish, we can fit a length estimator, which we can tabulate in each frame of the camera. We can attribute length to weight using a length-weight regression, and finally, we can estimate the area imaged using the field of view characteristics of the camera, which gives us the ability to relativize all of our quantities to units of meters squared or kilograms per hectare. And finally, we extrapolate lake-wide biomass using some combination of the area and different depth bins and or substrate characteristics. Allow me to use Lake Michigan in 2020 as an example to highlight some of the capabilities of the system. In 2020, we flew 300 kilometers of transects in Lake Michigan, and all the usable images are shown in the pink on the map on the right over the 30-meter isobath shown in blue. From our imagery, we screened 140,000 images and were able to identify 55,000 that were usable for fish and habitat identification. That is about 11 hectares from almost 0 meters to 46 meters depth. And also 43,000 individuals, just about. We used our length estimator to estimate the total length of more than 42,000 individuals, giving us the ability to map their length frequencies in overall and in different depth bins. Using the georeferenced biomass density results, we're able to map spatial variation in biomass in the summer of 2020, showing high biomass areas in the rocky reefs of the northern part of the lake, which contrasts strongly to the patterns evident in the bottom trawl in 2019. We also noted very high densities in some areas that essentially are more than an order of magnitude greater than the maximum densities observed in the bottom trawl. We documented strong differences in density between coarse substrates and fine substrates, some examples of which you can see on the right. We were also able to document a mean lake-wide weighted mean using the areas represented in each of these depth by substrate crosses of 6.72 kilograms per hectare. Finally, we innovated a way to extrapolate the results from the local scale, which we can classify with the AUV imagery, to the landscape scale by classifying substrate on the 3-meter LiDAR bathymetry surface that is served up by NOAA's lake level viewer. Environment Canada possesses 1-meter LiDAR bathymetry that could be used for the same purpose. We're using these data to arrive at empirical estimates of the proportion of coarse versus fine substrate in the 0 to 20 meter zone. Using GIS summaries of the area in each depth and substrate bin allow us to multiply by density to arrive at a kiloton estimate of round goby. The kiloton estimate we arrived at was 12.07 kilotons for round goby in Lake Michigan. When we compare our results to those of the bottom trawl, we can see much greater biomass. Again, here's 6.71 kilograms per hectare compared to the time series for bottom trawl estimated biomass of round goby. There's a number of other differences between the trawl and Gobybot, including the fact that we sample a great number of more individuals using Gobybot in a somewhat smaller area. I'm very happy to report that we successfully collected 150 kilometers of Gobybot transects in Lake Huron on the U.S. side in 2021, and we're aspiring to get a full 300 kilometers of effort invested in 2022, but this will very much depend on our ability to travel to Canada, and in case that we cannot, I'm hoping to find ways to either replicate our technology or share our technology across the border to accomplish a lake-wide survey. With that, I'd like to thank you for your attention and your time today and acknowledge the many individuals and organizations that have contributed to the success of this work. Thank you very much.